Okay, so I was gone on Friday. I do get sick occasionally. I haven't had many sick days this year, but I was sick on Friday. There was no doubt in my mind, like, oh my gosh. I was just not feeling well at all. Thankfully, I've recovered. But you had a sub, so I hope you learned what you were supposed to learn. I will review it a little bit, but it's on you. You had a video that I made. It was me explaining how to do the stuff for the day. So don't think that I can just like have a day off. We have the test, and the test is Wednesday. Yes, that's coming very soon. Today is Monday. So this is the last day of new stuff. Tomorrow's a review, test Wednesday. And what's it on? Well, exponentials, where there's an x in the exponent. So everybody, let's just start with like the most basic exponential, 2 to the x. I've said this a million times. If you want to make a graph, you can always make an XY chart. So you can just pick some numbers and stick them in. So like put in 0, and everybody figure out what 2 to the 0 is. 1, correct. And then graph it. That's on the graph of 2 to the x. And then put in 1. 2 to the 1. Y equals 2 to the 1. Y equals 2. Over 1, up 2. And you'll see the graph looks like this. It goes up really steeply. If you go over 2, it's going to be 4. There is an asymptote on these, like right there, and that is an exponential graph. Does that make sense to you? 2 to the x. It's exponential. Okay. Well, there's a new graph in town, and it's e to the x. But before we do that, what would it have been if I'd said 3 to the x? Well, obviously it's bigger in some way. What that really means is that it goes steeper. So like this would still go through 0, 1, but it goes up even faster. Okay, so here's the big picture. 2 to the x looks like this-ish. 3 to the x looks like this. 4 to the x looks like that. They just get steeper and steeper. The red one is like y equals 3 to the x. The black one's like y equals 4 to the x. And the bigger you make the base, the steeper the thing goes. But why do they all go through this then? Because when x is 0, do you get anything to the 0? Comes out to 1. That's why they all go through that one spot. And there's an asymptote for all of them right there. Why? Because no matter what you put for a power, it'll never turn it negative. Powers can't turn your answer negative. Okay, so it can't go below 0. All right. So then what the heck is y equals e to the x? Well, it is also exponential because it's got an x in the exponent. But then it kind of begs the question, what the heck is e? E is a number that is a lot like pi. Do you get that pi is a number related to circles that goes on forever and ever and never repeats? E is like that too. And just like pi, you can summarize and say it's about 3.14. Do you get, I'm not going to make you memorize E out to 100 places. No, I'm just going to give you a decimal for it. It's about 2.718. Would you agree that that rounds to around 3? Okay, so E is about 3. So pretty much I'm saying, when I say e to the x, I'm pretty much saying 3 to the x. I mean, it's off a little bit, but it's pretty close to that. So you already know what it looks like. You already know it's one of these graphs that goes like this. And could you make points for it? Sure. But if we're going to actually make points, we can't just say it's 3 to the x. We have to say it's e to the x, and we'll make points for that. We know it's about 3. And you might rightfully ask, where do you get e from? And I can't give you a great answer. Just like it's kind of hard even to describe where pi comes from, except at least you can say, here's a circle, and here's the diameter, and here's the radius, and then you could take this one divided by that one, and you get 3.14. But it's still kind of obscure. Where do you get E? E is a number that is found in nature, and it's especially apparent when you look at compounding, and you're going to use it in calculus, and so I'm going to push this off to the future, where your calculus teacher will be able to explain better about where E exactly comes from, because you're going to use it in calculus all the time. I know, that was super vague, but if I just tried to explain the origin of E the whole time, it would take another 10 minutes. And I'll show it to you in some formulas and try to show it to you there. All right, so there's E to the X, except it's an X and a Y chart, and you can put in any X you want, like what if you put in 0? What do you think you will get? 1. And if I put in X is 1, then I get E, yeah, because it's E to the 1, so it's E. Can you write E on the chart? Yes, you can. But then if you're like, how do I graph that? Well, have you memorized it yet? It's about what? Again, what did I say before?
3.
About 3. And 2.7 would even be better. 2.718. So if you're going to round it to one decimal place, like 2.7-ish. I would have accepted that as a kid's answer. I would also accepted just E. But I get it's uncomfortable to try to graph where the heck is E. So 2.7. So make sure that when you go over 1, that you go up 2.7. To me, that feels like it should be more like there. So I'm going to actually adjust my graph and say I wasn't going steep enough. It's almost like a base of 3, which is pretty steep. And I made it look straight. I don't want to make it look straight. It should be curving. But it's going up so fast, it looks almost like a straight line. There, that's more of a curve. How many numbers do you need? Actually, a couple like that with the asymptote would be enough to graph it. There's E to the X. It's pretty much 3 to the X. All right. So, again, you'll see that E becomes a really big deal in calculus. But for right now, all we need you to know is what's the graph look like. Looks like that. So what if I said E to the X except -1? Well, you got to know all of these moves and shifts and stuff. That would go down 1. What if I put a 2 in front? What would that do? Stretch. Vertical on the outside, so that's a VO, so then that's vertically moved down, vertically stretched. What if I wanted to put something on the inside? It's inside by the X. That would make it 4 times horizontally. Nope. Opposite of what you would think. 1/4 horizontally. And another thing you could do is take E to the X, and then in the parenthesis, in with the X, you could put like -3. That would move it 3 to the down 3? No. Right 3. Okay, so can you tell me, if I give you this equation, 4e to the x minus 2 plus 1, you should be able to tell me what that, and that do. It moves the graph this way, stretches it that way, and then moves it this other way. Will, what did you get for the 4?
Vertical stretch.
Stretch. BFO by a factor of 4. That's a very accurate answer. Good job. Okay. How about that 2 there? Ethan. What that does? Hint. Stuff on the inside is horizontal on the inside. So it's horizontal like this. So right 2 is correct. And lastly, we have this 1 out here. Okay, you got that one?
Up 1.
Up 1. All right, good. Now, if I actually had to graph this, there is no way that I would have tried to just go, okay, it's like this, except now I'm going to vertically stretch it, move it up 1, and move it to the right 2. That would have been almost impossible. So what do? You make an XY chart. And you stick in any numbers that you need to. Like what's a good number to start with? 1? No. 0s? Nope. Because then I got to do 2e to the negative second power. That's gross. 2 would be a good call. X equals 2. You try to make the inside 0 correct. So you put in a 2. And then you just made the inside 0. And then that whole thing is equal to 1. And then 4 times 1 is 4, plus the 1 on the outside makes 5. You get how I got a nice clean number out of that? You just stick in numbers that work nice. Another number that would work nice here is 3. Because then your power is really 3 minus 2, which is really 1. And then e to the 1 is really e, which is about 3. 3 times 4 is about 12, plus 1 is about 13. And I don't know if you know this universal sign for about 13. It's squiggly equals. That's me saying, I know it's not 13, but it's kind of close to 13. Squiggly equals. You can do that on your test. So I'd graph it and say it's about 313-ish. Yes?
On the test, if we were to do regular 13,
You shouldn't act like it's exactly 13 when you rounded 2.7 to 3, because it's definitely going to not be 13. So yeah, you better say something about how it's not 13. All right. So let's get to the actual assignment here. Do you remember how to make these where the start goes here, and this is the base, and this is the time? I know from looking at the equation what they started with. I know what the base should be. They don't tell me a time in this situation. Catherine, what do you think they started with?
500.
Correct. The number on the inside, max.
1.25.
Correct. If you put 1 plus 0.25, I'd be good with that too. And they did not tell me the time, so I leave that alone. So here's my answer. And if you tell me a time, I can tell you how much I have. And that brings us to today's stuff, which is about real world situations. Let's say that you are trying to grow cattle. I just saw an article about Zuckerberg, who's the guy who in college invented Facebook. And let's say that you're a rancher and you got 500 head of cattle, and you do your math, and your cattle can grow by 25% if you do this right and they stay healthy and stuff. Your herd will grow by 25%. Well, how often? That's a key question. 25% a day? No, that doesn't make any sense. But it might be 25% more every year. And of course, in the real world, you don't just let your cattle farm grow to gigantic numbers of cattle. But if you get 25% growth, this is how you would model that. So we have real world situations. Instead of giving you like an equation like this and saying it was 15% decay, we're going to say we have a car, and the car is losing value at 15% per year. And then you have to write it here. Remember, the start goes here, whatever it starts as. And then I always put 1 plus or minus. I personally put 1 minus 0.15 here to say the car is losing 15% of its value. All right, so let's get into some, 2 seconds for graph of exponential decay. We talked a lot about growth. That's like the blue one. Decay is like this red one. And there are real world decays in things. My favorite example right now, because I'm living it, is the decay in the cost of a Tesla. The electric cars have gone down in cost a lot, and they're going lower every day. And by the time you want to buy a car, man, they're going to be so much cheaper than when I bought it. So, yeah, there's actually decay in the cost of cars. Not all cars. Gas cars aren't going down like that because gas cars have been around for so long that they're not shrinking anymore. But electric cars are pretty new. They're only like 10 years old, so they're still shrinking in cost. All right, that's exponential decay. On to this one. Now, this one is going to be another one where your calculator will definitely be allowed on the test. And if you've got a calculator, this would be a great time to take it out. If you want to borrow one from me, you can. And I think some of you know that if you log in single sign-on, you can do it on your iPad. One of those ways, you're going to need a graphing calculator. If you wish to borrow one from me, come forward. I'll happily lend you one. That'll leave me your cell phone as collateral. These things cost me a lot of money. I have several. Just ask. Swap it for your phone, which you can't use now anyway. Tate, where's your calculator? All right. Max, you got a calculator? Okay, good. Thank you. Just couldn't see it. All right. So we are rolling. So what do? Well, you write one of these, and you stick the start value here. You put the time right there, and you'll see how much this one is the end. If the other one's the start, the end number you get, like how many cattle do I have now, goes right there. Okay? So, I wrote this problem, I remember it. He takes the census and determines he's got a population of 18. I thought the census idea was kind of funny. He reads up and determines that it'll grow by 15% per week. So y equals 18 to start with times, what's it growing at? 15. So 1 plus 0.15 to the x. And normally it tells you how often it's happening. If you don't know that, you really can't do the problem. So then this is a weekly formula. The formula is in weeks. How many will it be in 3 weeks? Well, then you put a 3 here. But do you get if they'd have said 36 days, you couldn't put a 36 there? You know what I mean? The formula is written for weeks. So if they give you 36 days, you can't just stick a 36 there. You'd have to change it over to be like, oh, okay, well, I got to figure that out in weeks then. All right, so since it is in weeks, I can just stick it right there. And there's my calculator grinding out my answer, and this is the end value. Did you got it?
Yeah, I got 27 calculations.
Anybody else around to 27?
Yeah.
Yep, looks like people are verifying your answer. Yay, that's all there is to this, but they get more complicated. I want to not help you, and I want you to remember to set up one of these equations and just try to answer it, but start with the equation. If you don't have the equation, you don't have your work. And if all you have on the test is the answer, we're marking it wrong. You gotta show your work, which is the equation. Hint, it's been 6 years. We have the beginning and we have the end. What we don't have is the rate. So if you write this equation right, the only letter in it, the only variable, the only thing we don't know is R. I gave you a couple hints there, but let's see if you can pull it off. Okay, here's a crucial part. Let's see if you set it up right. So you put the start here. What was the start value of the house? Its value was $229,500. So $229,500 was the start value. Did it increase or decrease? So I put a 1 plus, and then I don't know the rate that it increased at, so I put an R. How long did it take? 6 years, so the time is 6. What did it end at? 279. This is a very real scenario. Houses change in value a lot over time. Sometimes they go down, usually they go up, like this one did. And then you can figure out what the rate of growth was. Your first step should have been to divide both sides by 229,500. That'll make this cancel. What is 279,900 divided by 229,500? Is that what you guys got? 1.2196. 1 plus r to the 6th. And if you got that far, I bet you knew that you should put it to the 1/6 power. Now, some kids round. Even if the answer says to round, don't round till the very end. Do you get if I use 1.2, it'll be way different than if I use 1.2196? It will be way different. I know it's tempting to round, but don't round till the very end. What is 1.2196 to the power of 1/6? Oh, it did it. 1.0336. Subtract 1 from both sides. 0.0336. And to me that says that's an interest rate. That's an inflation rate. I can see that makes sense. It's about 3%. It all depends now what you want to round to. Does it say what to round to? I don't think the problem ever said what you should round to. Just the annual percentage rate increase. Well, then it'd be as accurate as possible. I'd say it's about 3 point, and then that 3 would round to a 4. I would have said 3.4%. But if you rounded different than me, that's open to interpretation. Who had that without any coaching from anybody else? You figured it out. Nice! You guys are better at this than I thought. Okay. So I'm going to give you a real world scenario that involves my daughter's house. She bought it for $410,000 2 years ago. This is real. Current value, $450,000. If that's the scenario, what was the rate of growth in the value of her house? The real world is much more complicated because during that time she made some improvements to the windows and that cost her some money, and there's a lot of things in the real world that make this complicated, but our equation would start with 410. One plus, I don't know what the rate was, but it was 2 years ago. And the end value goes here. Please figure out the interest rate. I'm going to pause for a second. Once you get it down to 6.2% or whatever, talk to the kid next to you. Okay, so we used our formula. We stuck in that n was 1 because this was just an annual scenario, 1 time per year. And I then put all my numbers in. I divided both sides by 500. I got 2 here. And then I'm putting it to the 1/8. To the 1/8. And this became 1.0903 or something like that. We're just going to round it off to 9% anyway. Subtract 1 from both sides. We got about 9% is the rate. We were getting 9% growth on our money. This is Rita wants her money to double in 8 years. So this is called the rule of 72. 9 times the 8 makes 72. I could riff on that for another 15 minutes, but the rule of 72 is kind of cool. You want your money to double in 10 years? You take 72 and divide it by 10, and you need 7.2% interest to make it double in 10 years. It always comes down to 72. It's kind of weird, but it's true. You want your money to double in 36 years? Then you need 2% interest, because it always comes down to 72. Weird but true. Rule of 72. Okay, let's get to your homework. Homework for today. Oops, I should show you this. PERT. That is another formula. That P-E to the R-T. I will tell you tomorrow whether or not you have to memorize this one. But it's got E in it. We started the hour with that. It's been a long time ago. What's it about? 3. If you had to get closer to it, it's about 2.7. Anybody go further? 2.718. Very good. Okay. And the calculator does know E. If you wanted to know E, you can find the little E on your calculator, hit enter, and it'll tell you 2.718. But it doesn't even go forever. It just gives you a longer decimal. What about 2.7 for E? Anytime you want to use E, put in about 2.7 and we'll be good. You want it more accurate? Put in 2.718. You want it super accurate? Use the calculator, E button, and it'll put in 2.718. What is after that? Remember? 8281, etc. Okay. Okay. Now your homework is tremendously too big, so we will just do the first couple problems with you, and then I'll tell you which ones to do and skip. Number 1. Jack, would you read me number 1?
Cost of turning down cereal increased from $4.25 to $5.50.
How long did it take to increase to that?
5 years.
5 years. All right, so I do my little formula. Y equals the start amount times 1 plus the rate to the time. And I stick in my numbers. The start amount was 425. The ending amount was 550.
No, $5.
Was it 550?
Yeah.
Okay, good. And then 1 plus the rate. Nobody tells me the rate, so I leave it as R, and the time is 5. And then you just have to solve from there. First thing, divide by 4.25. And then you'll put it to the 1/5 power to get rid of the power of 5. And subtract 1 at the end, and you'll have your answer. All right. I'll pause for a second while I figure out which ones to skip. Okay, so you're doing problems 1 through 4. This is for the sake of the video. And 6 and 8 off of that worksheet. That should be a total of 4, 5, 6 questions. That's it. We already did number 1 together. I guess we never finished number 1, but what did you get for number 1?
5.3%. Yeah, that's what I got.
Yep, because you're verifying 5.3% for the first one. Okay, good. All right, if you get stuck, please come up and ask. That's all I got for the video for today.